If you've ever written any code in JavaScript, you might have noticed that it's a little bit of a strange language, and there's a lot of unexpected behavior and weird things that go on. Now, this leads many beginner and junior developers to making a lot of mistakes in JavaScript simply because they don't know about these weird features. So in this video, I'm going to share with you the top beginner JavaScript mistakes and how you can fix them. With that said, let's dive in. So first thing to mention is that if you want to get better at programming and become a software engineer, I do have a course. It's called programmingexpert.io. I'll leave a link to it in the description. And if you're interested in blockchain or Web3 technology, I have a course for that as well. It's called Blockchain Expert. Again, that will be in the description. Now let's dive into mistake number one. So the first mistake that many JavaScript developers make is misunderstanding the use of the double or the loose and the triple or the strict equality operator. So in many programming languages, you only have access to the double equal sign, which tells you if two objects are equivalent. However, in JavaScript, we have the triple equal sign, which tells you if they are strictly equivalent. Now, that means that a lot of people mix this up and they use both of these operators kind of willy-nilly without understanding what the difference is. You should always use the triple equal sign here, the strict equality operator, unless you have a reason to specifically use the double equal sign, and that's what I'm going to talk about now. So notice here that I have my number 1 equal to the number 42 and number 2 equal to the string 42. Now these are different objects, they're different types, and really they are not equivalent. However, when I use the double equal sign or the loose equality operator and I run my code, notice that it says that they are equivalent. Now that's because the loose equality operator is going to convert the first number here into a string and then compare the two strings against each other to tell me that this is actually true or equivalent. Now this works with other types as well and can give you some strange behavior if you're not careful. For example, if I compare null and undefined using the loose equality operator, notice we get true. If I compare something like false and then the string false here, notice that we get false. So it's not necessarily intuitive, right? In this case, you would have thought, oh yeah, that's going to tell me it's true because it'll just convert the Boolean to a string or vice versa, but it doesn't. Now let's look what happens if we do it in the other order, just for a sanity check here. If we go false, double equal to the string false, then we get false as well. So just showing you there's some very strange behavior. Now continuing, I can say false is double equal to undefined. Okay, so that's equal to false. What about false equal to null? Okay, so that's false. So not necessarily intuitive, gives you a lot of weird results, and that's why I wanted to show you here that when you're using this double equal sign, it's checking for loose equality, where it's going to attempt to convert the different types into one another. So instead of using that, you should use the triple equal sign like this. Now, when you use the triple equal sign, this is a strict equality, which means that you're only going to say that something is equal if it is the same type. So in this instance, when I use the triple equal sign, if I go and say node and then solution.js, you can see that it says using triple equals, num1 and num2 are not equal. And then we could repeat all of those examples that I showed you with the triple equal sign, and you see that they would not be equivalent if they were not the same type. All right, so the next mistake that many JavaScript developers make is misusing the var, let, and const keywords, or using them synonymously when they actually do have different use cases. Now, when we're declaring variables in JavaScript, as I just said, there's 3 different ways to do this. We can use the var keyword, the let keyword, or the const keyword. Now, a const is going to be used when we're declaring a constant value that cannot change. Let is going to be used when we're declaring something that can change, and then var will do the same. It will declare a variable that could change. However, var and let are not the exact same. They're not synonymous. They work differently, and the way that they differ is in the scope in which they define a variable. A lot of people don't know this, but you cannot just treat var the exact same as using let. So have a look at this example, pause the video if you want to, and kind of read through if you could understand, but I'll walk you through it. So you see that we have a function here, and inside of the function, I start by declaring a variable using the var keyword. Now, when I do this, we're actually going to declare a variable within this scope, okay? The scope is essentially going to be the nearest function that we're inside of. Now, there's some other weird edge cases there, but in this case, it's kind of the nearest function that we're enclosed in. So in this case, it is example. Okay, then we say if true, so we're just executing this if statement here to create a new block. We declare another variable with the same name as this using the var keyword. Now, obviously here, when I go to print this out, we're going to print out the value of 2, which is this new variable that was declared. However, when I come outside of the block here, notice that I will be printing 2 as well, when you might have thought that I would have printed the value of 1. Now, the reason we're getting 2 here is that when I use this var keyword, it doesn't declare this variable inside of the block, it declares it inside of the current scope. So the block is the if statement, the scope is the function. So it actually overrides the value of the variable that existed before it in the current scope to be equal to 2, which is different than what the let keyword does. So now if I come and I have a look at using let, you can see that we define let equal to 1. We say if true, then we define it equal to 2, and then we print out what the value is inside of this if statement block. In this case, it's 2. However, when we exit the block, it's equal to 1. Now it's equal to 1 because let only defines the variable within the current block, not within the current scope. So this variable only accessible and usable inside of this if statement block, and then outside we revert back to using this one because this statement did not modify or override this variable. Hopefully that makes a little bit of sense. Var is the current scope, which is the function. Let is the current block, which would be something like an if statement, for loop, etc. Then we have const. Now when we use const, it's going to do the current block as well. So exact same as let. So you can see here, we say it's equal to 1. We come in and we define the constant equal to 2. Inside the block, it's equal to 2. Outside of the block, it is equal to 1. Make sure you understand those important differences and you use var, let, and const accordingly based on that. So the next mistake that many JavaScript developers make is misusing mutable and immutable types or not understanding the difference. Now in JavaScript, we have this concept of mutability. This means that some objects are mutable, meaning they can change, and some are immutable, meaning they cannot change. Now, this is a very important concept to understand, especially when you're working with objects or nested structures. So before I actually dive into this example, I'm just going to illustrate a immutable object so you can see the standard and typically expected behavior. So let's say I have a constant x is equal to 1 and a constant y is equal to x. And then I say something, actually, let's make these lets so that I can change their values, like x plus equals 1 and y plus equals 2. Now in this case, what happens here in this example is we define x equal to 1. Now 1 is an immutable object. That means once we define it, it cannot change. And then we say y is equal to x. Now that means that we are going to essentially copy whatever the value inside of x was into y. So now y is equal to 1 as well. However, it's a different 1 than the 1 here. So now if I say x plus equals 1, x becomes equal to 2. And then if I say y plus equals 2, y becomes equal to 3. Me changing x or y does not affect the other variable, even though I had something like let y equals x. I know this seems completely trivial, but in some cases, you might actually think that because I said y equals x, now if I change y, it affects x. And if I change x, it affects y. But that's not the case because this is an immutable object. So in JavaScript, types like booleans, numbers, strings, these are immutable, meaning once we define them, they're not going to change. And if I assign them to another variable, so something like y equals x, now y is a copy of that object. Now this is different when we look at immutable objects like arrays or objects. So if I have something like an array here, and then I say let y equals x, and then I do something like y.push1, what actually happens is both x and y now are the array that contains 1 inside of them. Now, the reason for that is when I'm storing an array or any mutable object, I'm actually storing what's known as a reference to that object. So when I act on the variable, I'm acting on the reference, which then modifies the underlying array, which can be pointed to by multiple different variables. So here, x is essentially this. X goes to a reference, which goes to this array. And then when I say y is equal to x, what I do is I copy the reference to that same array. So now if I change x, that affects y because I'm changing what the reference points to. Y was not storing a copy of x, it was storing a reference to x, meaning any change to x affects y and any change to y affects x because they are pointing to the same underlying object. So this can be better illustrated with the example I have on my screen. You can see I have a person object with a name, age, and address. Now I create a new object using the original person object. So I say updated person is equal to person. Then what I do is I change the name of my updated person to be Jane Doe, and I change the address.city to be equal to Los Angeles. So now if I open up my terminal and run my code, notice again I'm printing the person and the updated person, that I actually get the exact same object and the exact same data. So again, keep in mind, I said updated person is equal to this person object. You might assume that makes a copy of the person object, but it doesn't. It makes a reference to the original object. So now when I do things like update the name or update the city of the address, what that does is that actually affects the original object, which is both of these variables. So updated person and person are both pointing to the same object, hence why when I make a change to one, it affects the other. So how you can avoid this? Well, you can make a deep copy of the actual object. Now, first of all, I just want to show you that if I do something like ... person using the spread operator, what this will do is copy all of the properties of my original person. So now, if I run this, we're going to get a slightly different result where you can see that I get a different name. So I have John Doe, which was the original name, and then I have Jane Doe. However, notice that the city in my person is still changed to Los Angeles. So again, just have a look here. We update the name and we update the city of the address. So in this case, I retained my original name in the person object, but the city still changed in the address. Now, the reason for that is when I do this copy operation, this is what's known as a shallow copy. It's copying all of the properties. However, since one of the properties is an object, it's essentially copying the reference to the object associated with that property. Now, that means when I change something on that object that wasn't deeply copied, it was just shallow copied, it's going to affect the underlying object, which is nested inside of the person object. I know that seems a little bit confusing. Feel free to pause the video and kind of read through this, but you need to understand what happens when you're working with these mutable types. So to fix this, we'll have a look at our solution here, and you can see that what we're actually doing now is we're using a form of a deep copy. Now, there's better ways to do a deep copy in JavaScript. Won't get into that right now. Essentially, the way we deep copy everything that exists inside of this person, including the nested object, is we say JSON.parse and then JSON.stringify the person. So we convert the person object into a string, which is an immutable type, and then we parse that string as an object, and that gives us a brand new object, which is a deep copy, an actual copy, not just an alias or a reference to this object. So now if I come here and I run my solution, so let's do that, you can see that our address does not change in the original object. All right, the next mistake that many JavaScript developers make is not understanding the difference between the context of the this keyword inside of arrow functions and regular functions. Let's have a look at this example so you can see what I mean. So first of all, when we define a function, this is different than defining an arrow function. A lot of people just use them synonymously, and they think that an arrow function works the exact same as a regular function. Now, in a lot of scenarios, it does, but if you start using this keyword, so the one that's in orange here, it works differently. So if we have a look at this example, we have a function. This is kind of a factory for a car object here. And what we do is we return a make, model, and year for the car, and then we have two functions, one that's a regular function and one that's an arrow function associated with these properties. Now, they do the exact same thing, just one is a regular function, one's an arrow function. Now, if you look at all of the comments here, you can see that when we use the regular function, we get the output we expected, right? We get the make of the car, the model of the car, and the year of the car, and that's because when we use a regular function, this is bound to whatever called the function. So when I call the function using my car, this references the car that I called it on, which has the make, model, and year on it. However, when we use an arrow function, this is actually going to inherit whatever the current this context is where it was defined. I'm going to show you an example of that in 1 second, but what that means is that since this was defined inside of this function, it's going to inherit this context from this function. Now, this context of this function is currently the global scope, which means it's going to reference global. I know this seems a little bit strange, but essentially we're inheriting this context, whereas here the context is different based on what invoked or called the function. So just to prove to you that I'm not making this up, let's change into directory 4 and let's go node and then mistake.js. And you can see that we get what we expected. And then when we use the arrow function, we get undefined values. So now let's have a look at the solution and you'll see what I mean with the arrow functions. So when we have a look at our arrow function now, you can see that what this is actually going to do is inherit this context from where it was defined. So go ahead, pause the video if you want to understand this more, but we have an object. Inside of the object, we have a name property, and then we have a property that is a regular function. Then inside of that function, we define another function. So now the arrow function inside of this function inherits this from the function it's defined inside of. So now when I call say hello from my object, this arrow function's this is going to be whatever this is from the function it was defined inside of. Very hard to explain because this is a word that I use to explain, and it's also the actual word that I'm talking about, but hopefully this makes a bit of sense. So if I run this now and I say node and then solution.js, it says hello from John, and then the arrow function says hello from John as well. Again, that's because the context of this keyword in the arrow function inherits from wherever it's defined. In this case, it's defined inside of a function that is going to have this context be equal to whatever object called it. So when I reference this .name here, it's referencing the object that called it, which has the name John. So moving on to our last mistake, and this is mishandling asynchronous code. So let's have a look at this example here. We have a fetch data function. Now this function is essentially mimicking the result of an API call. So let's say you use the fetch function and you're attempting to get some data from an API. That's what this is attempting to mimic, okay? So what we're doing is we're returning a new promise. The promise has a resolve and a reject function. And the promise is just a set timeout that waits for 1 second before it calls this resolve callback function. Don't worry too much about this if you don't understand how it works. Essentially what we're doing is we are triggering the .then, if you're familiar with that in JavaScript, after 1 second. So what I'm doing here now, incorrectly, is I'm saying, okay, I want to get the data from this function. I want to retrieve this from my API. So I say data is equal to fetch data, and then I print out data and then whatever the result of data is. Now the mistake here is that I didn't wait for this data to be returned. So what happened is I get the result promise pending. Let me show this to you. If we go into directory 5 and then we say node mistake.js, you can see that I get promise pending. The reason I'm getting that is I essentially immediately print whatever the result of data is before I wait for this promise to resolve. So at that point, it's just a promise that is pending data. So how am I going to fix this? Well, if I go to my solution here, you can see that now we have two ways to actually handle this correctly. The first way is to use the .then and the .catch, and the second way is to use async and await. So let's start with .then and .catch. Now what we can do is on a promise, we can use this .then function. What .then will do is trigger as soon as the promise resolves. So as soon as this resolve function is called internally from the promise, a lot of times you don't actually see that, it's happening behind the scenes, then this will be triggered, and then you can actually go ahead and print the data. This is essentially saying, hey, wait for the promise to resolve. Once it resolves, run this function, and then execute this code. Perfectly fine. Then we have our catch, and the catch is going to run when the promise resolves to an error. So when the promise rejects, really, and that's pretty much when it runs, right? So if an error occurs, then you go into .catch. If an error doesn't occur and the promise resolves correctly, you're going into .then. Now, one thing to note here is that when you do this, you're not going to have blocking code. What that means is that if I go down here and I say something like const num is equal to 1, this line is going to execute immediately. It's not going to wait for this promise to resolve. So that's kind of nice because what you can do is say, okay, I want to do this kind of stuff once this promise resolves, but I don't want to block my code. I want to continue going down from there. So that's what happens. We continue executing the rest of the code in the function. And then as soon as the promise resolves, we'll actually print out whatever the result is here. Okay, so that's way one, using .then and .catch. Way two is to use async and await. So inside of here, I have a try-catch block. Now I'm using a try-catch block because there could be an error that occurs that I actually want to handle with my promise. Anyways, what I do is I say const data is equal to await. Now when I say await, this is a blocking keyword. And what this means is I'm going to wait for the promise to resolve. That's exactly what happens here. Now the reason why I needed to put an async here before my function is because to be able to use the await keyword, I need to be inside of an asynchronous function. So if I put async, then I have the ability to use the await keyword. Now here, when I say const.log data with async await, I'm only going to print this line once the promise resolves, because I'm essentially waiting, just kind of stalling right here on this line, line 26, until I get that data, then I print it out. Now that's different than if we go back here where I said const data is equal to fetch data. At this point, I'm not waiting. I'm just saying, okay, trigger the promise, and then we go immediately to the next line. Whereas if we go back here, we're waiting for it to resolve, then we're printing out the data. Now it's important here that we have this try catch because again, there could be an error that happens inside of our promise. If that's the case, then we want to handle that. And since we're not using the .catch like we are over here, we need to kind of do that manually with our try catch block. Okay, So with that said, that's going to wrap up this video. These are the common mistakes that JavaScript developers make. Hopefully you found this helpful and I showed you how you can avoid making these mistakes in the future. If you did, make sure to leave a like, subscribe to the channel, and I will see you in the next one.